Oh, that familiar music that marks the start of every skating competition. It quickens the pulse and might even instill a sense of dread in the skaters that are waiting to step on the ice. As a data specialist, when you hear that music, you might be experiencing some anxiety too, hoping and praying that everything will go well with the competition scoring system. You hope that no weird error messages will pop up, that nobody will tell you they have the wrong skater on the screen, or worst of all, that the referee says those words that no data specialist ever wants to hear. Folks, we're going manual. My name is Paul Mallet. I'm a data specialist from the Skate Ontario section, and I am pleased to introduce this final installment of a 3-part video series on computer networking for data specialists. In this module, we'll be examining some common problems that can prevent a CSS network from functioning. We'll cover some of the critical questions that you should be addressing when you're trying to troubleshoot a network problem. For the most part, the answers to these questions will be determined by testing the connectivity of various parts of your network. And then we'll also look at some common problems that might prevent your video replay system from functioning. So let's have a look at the typical network configuration for a CPC competition scoring system running in laptop mode. We have a router controlling a subnet, which is 192.168.6, and the router has a host number of 1. Connected to the router is a 16-port unmanaged switch, and connected to this switch are an EC laptop with a static IP address of 192.168.6.50 and other laptops that are all configured to obtain dynamic IP addresses. Running on the EC computer is an SQL server that's hosting our competition database. I've put together a list of some of the most common problems that you might encounter, especially right after setting up your network when you test it for the first time. This list isn't exhaustive, there are certainly other things that could go wrong, but this covers most of the common causes of network problems. So there might be no power to the router or switch. The switch might not be plugged into the router's LAN ports. Somebody might have forgotten to connect the switch and router all together, or they might have accidentally plugged the switch into the router's WAN port. Another possibility might be that the EC's computer firewall is turned on, which is then blocking the network traffic to and from the database. Or the SQL server might not even be turned on. Problems can also be caused by a faulty, loose, or unplugged Ethernet cable, a laptop network adapter not being configured properly, using the wrong IP address for the database location, or having an improperly configured database location setting. So there are lots of things that could be responsible for a network fault. And a challenge for the data specialist is that all of those different problems could potentially manifest themselves in the same error message from a user's perspective. For example, if the firewall is turned on the EC computer and you sit at the referee's laptop and try to log into LTS, you'll get a database could not be found error message on the screen. But you'll also see that same error message if the referee laptop Ethernet cable is unplugged, or if there's no power to the router, or if the switch is plugged into the router's WAN port. So the error message in itself isn't terribly useful for identifying the source of the problem. Now looking back at our network schematic, let's say that the problem is that the referee's laptop Ethernet cable is loose or unplugged. The connection to the switch will be lost, which is shown by the gray line in this diagram. But the network connections for the rest of our devices will still function, which is shown in this diagram as green lines. Now imagine that we had a different problem that was causing the error on the referee laptop. In this case, the problem is that we have no power to the router or switch. This hardware problem might still produce a database connection error message on the referee laptop, but in this case, the entire network will be down, and therefore the problem will not be isolated to the referee laptop. So this brings us to the first critical question that you should be asking yourself when troubleshooting a network problem. And that question is the entire network down, or is the problem isolated to a single host? If the problem is isolated to a single host, you can immediately rule out many of the possible network software and hardware issues responsible for the problem. So in this case, because some of the hosts are still functioning normally, we know that the router and switch are functioning. We know that the EC computer's firewall isn't turned on because it would otherwise block network traffic to all the laptops. And we know that the SQL server is up and running, because if it wasn't, we would be seeing error messages on all the scoring system laptops, not just one host. Knowing whether the problem is affecting the entire network or a single host is certainly a useful beginning as you work through a process of elimination to identify the specific fault. But you'll need another technique to better isolate the fault. And this is where testing whether there's a route between a computer and the router or between two computers really comes in handy. So let me explain this with a specific example. So here's a typical scenario that can occur shortly after unpacking and setting up all your equipment. You have 30 minutes left before the competition begins. To the best of your knowledge, everything is plugged in and everything is turned on. You decide to test the system by logging in all the LTS computers and entering elements, GUIs, and PCs for a test skater from a dummy competition in your database. When you try to do this, none of the LTS computers are able to log in, and instead they all show an error message indicating that a database connection could not be established. So this type of problem could be caused by almost anything. Coming back to our original list of common problems, any of these could be the problem. But you have limited time before the competition starts, so time is of the essence, and you need to use a better approach than checking every possible problem. So in a situation like this, given that all the computers are involved, I wouldn't waste my time on any of the computers running LTS. I would concentrate my efforts on the possibilities that could prevent the database located on the EC computer from being reachable by all of the other computers on the network. I would start by logging into CSS using the EC account, and in that process, confirm that CSS is configured to the database running on the local host. Now, if you confirm that and you're able to log in and access the database, then you can confirm that the SQL server is up and running on the EC computer. So there's no point looking at the SQL server. Now, still working on the EC computer, the next thing to check is whether you have a network route between the EC laptop and the router. If there is no network connection between the EC and the router, or if that connection is being blocked because of a firewall, then none of the LTS computers would be able to connect to it. So this may well be the source of the problem. So this takes us to our second critical troubleshooting question. And that question is, can the affected host reach the router? Now, to do this, I don't mean to start crawling around under tables to check whether things are turned on or plugged in. You can determine whether you have a functioning network route from the computer to the router with a single command. This is probably the most useful command you'll ever use when troubleshooting a network issue. In other words, your best friend to help you get your networking issue sorted out before skating begins is the command ping. The term ping dates back to World War I, when sonar technology was invented to determine the presence of objects below the surface of the sea, such as submarines. Sonar uses sound waves for this. A sound, or a ping, is created, and then the characteristics of the reflected sound wave are analyzed to determine the position and distance of underwater objects. In computer networks, the command ping is used in a similar way. But instead of emitting a sound wave, data packets are sent to an IP address, and the recipient computer then answers back. The time in milliseconds for these data packets to return is measured and is used as an indication of network latency. So how can we use this information? Well, The measured network latency, turns out, is not really important for diagnosing a network connectivity issue in our competition scoring system. But the fact that we're receiving a response to our ping request from the target IP address tells us that we have a functioning network connection between the computer initiating the ping command and the network device that is responding. Compare that to a ping command that is not being answered by the receiving network device. So here we see that 4 data packets were sent to the IP address 192.168.61, and no latency values were returned. So this tells us that we do not have a functioning network connection to the target network device, either because there's no network route or because an active firewall is blocking the network traffic. So coming back to the example where none of the laptops were able to log into LTS, if I can establish that I can successfully ping the router from the EC computer, then that rules out many of the possible problems. I know that the router and switch both have power and are routing network traffic. I also know that my EC computer has a valid IP address on the 192.168.6 subnet, because if it didn't, I wouldn't be able to connect to the router IP address and my pings would not be returned. So I'm left with one of 2 likely possibilities. One is that the Windows firewall is turned on the EC computer. Another is that my EC computer IP address might not actually be 192.168.6.50. I know it's on the correct subnet because my pings to the router were returned, but it's possible that somebody changed the network adapter settings so that the EC computer is now using a different static IP address, or perhaps the network adapter was set to obtain a dynamic IP address. I can quickly check these 2 things right here from the EC computer. The first thing I would do is check the IP address by issuing the ipconfig command, which I described in Module 2 of this video series. When I do that, I notice that my IP address is 192.168.6.50 as expected. So the next thing to check is that the Windows firewall is turned off. To do that, I can simply type firewall into the Windows search box, then open the firewall. And there's the problem. My firewall is turned on. There are actually 3 different Windows firewalls that can be activated, and depending on how your network is set up, it's not always obvious which is the correct one. So to be safe, turn them all off. Lo and behold, when we turn off the firewall, all the laptops are now able to connect to the database. Okay, let's look at a different scenario now. We've again just set up our entire scoring system and everything is working fine with one exception. The Judge 2 laptop won't connect to the database. All the other computers are working fine. So again, the first critical question to consider is whether all hosts are being affected or is it just one? Because it's just one, then we can rule out problems with the router, the switch, the EC computers, all those kinds of things that have a low probability. We are more likely dealing with an issue affecting just the Judge 2 laptop. The 2 most likely possibilities are that it's not connected to the network properly, or that the competition database location is not configured properly in LTS. So the second question that we should consider is whether we can connect to the router. To do that, we open a command prompt and we enter the command ping 192.168.6.1, which is the router's IP address. And we are receiving responses. Therefore, we are connected to the network. That's useful because it rules out any problems related to network cables, network adapter configuration, things like that. But for some reason, LTS is still unable to connect to the database. So let's check if we're actually able to connect to the EC computer, because that's where the SQL server is located. And that takes us to the third critical question that we should consider, which is to verify that we're able to connect to the EC computer. So we can use a ping command not only to check network connectivity to the router, but also to any other computer on the network. So we'll issue the command ping 192.168.6.50, which is the EC's IP address. And that is also returning our pings. So that leaves only one obvious problem, and that's the database location settings. So let's have a closer look at that. And there's the problem. Somebody has changed the setting so that it includes a / instead of a \. Let's change that, and bingo, it's working fine now. Okay, let's look at a third and final example of troubleshooting a network issue. This time, we again encounter a problem where none of our computers running LTS are able to log into the competition database. We turn our attention to the EC computer and test the network route to the router by typing ping 192.168.6.1. We receive timeout errors. So this indicates that there is a problem connecting to the router, but it doesn't tell us why. There may be no power to the router or switch or both, or they might be turned off. Another possibility is that the switch is not connected properly to the router LAN port. So we walk over to the switch and router and we see that all the indicator lights are on. So this tells us that things are turned on, things have power. And we also see that the switch is correctly connected to the router LAN port. So that's not the problem. So we go back to the EC computer. We then check to see if the network adapter is configured properly on the EC computer. To check this, we run an ipconfig command. We see no IP address for our Ethernet adapter, but instead we see a media disconnected message suggesting that the Ethernet cable to the EC computer may not be plugged in all the way. We checked that connection, and sure enough, that was the problem. So that takes us to the fourth critical question that we should consider when troubleshooting a CSS network. So to review, considering these 4 questions can in most circumstances provide a resolution to whatever CSS network connectivity issue might be occurring. The second and third questions can be addressed by issuing a ping command to either the router or the EC computer's IP addresses. And the fourth question can be addressed by using ipconfig to examine the Ethernet adapter's current state. To help you troubleshoot scoring system networking, I've created this downloadable diagnostic flowchart that should address most common networking problems. You can use the download link shown at the bottom or just scan the QR code. The diamonds represent decisions and the rectangles represent possible corrective actions. So working from the top down, you should first determine whether or not the problem affects all connected hosts. If yes, then you'll follow the green path on the right. So the next thing to check is whether the EC can ping the router. If yes, that rules out a lot of possible problems, and the most likely remaining issues are the firewall and the SQL server. If the EC can't ping the router, then you should start by checking that you have a valid IP address on the correct subnet. Here you'll use an ipconfig command for that. And if that's the issue, you would correct that by going into the Ethernet adapter settings. If that's not the issue, then make sure your router is turned on and has power, and that the switch is connected to one of the LAN ports. Failing that, you'll then check that the EC computer connections are good, and failing all of that, reboot the EC laptop. Now, the order of checking things in the rectangles doesn't really matter. I've put restarting the EC computer as a final resort because it takes time for the computer to finish rebooting, whereas checking the other things can be done more quickly. But the order that things are done really can depend on the situation. Going back now to the top level question shown in the black diamond, if only some of the hosts are affected, and typically when this happens it tends to be just one laptop, then the first thing to check is whether or not the affected computer can ping the router. So you'll use ping space IP address of the router in a command prompt. If it can ping, then it's likely a database location setting issue. And if not, if you can't ping the router, then you should turn your attention to the Ethernet adapter settings to make sure it's set to obtain a dynamic IP address. And if that's not the issue, check the Ethernet cable, and if none of that helps, finally reboot the computer. The final topic to be covered is troubleshooting video replay system issues. As I mentioned in Module 2, the information I'm covering now is specific to a system that involves using ISU Cutter along with a JTEC 1080p video streaming device. As a reminder, there are two ways of connecting these systems, either with or without a router. Not unlike the CSS network, there are a few things that can go wrong that will ultimately lead to the problem of there being no video image on Cutter. Some of the common problems include obvious things, such as no power to the JTAG box, no video feed from the camera to the JTAG box HDMI input, or the ISU Cutter settings might not be configured properly. But oftentimes the problem is computer network related, such that there's no network route between the VRO laptop and the JTAG box. And this can be caused by a variety of things, including lack of a functioning and connected Ethernet cable to the JTAG box or to the VRO, or the VRO laptop might not have an IP address on the same subnet as the JTAG box. In rare circumstances, the JTAG device itself might not be configured properly. I say rare because once you configure those settings, in my experience, I found the JTAG encoding devices to be quite stable. So I would typically only suspect a problem with the JTAG device settings if the device was newly configured or if a factory reset procedure was recently undertaken. Now, although any of these problems will present as the same issue, that is, there is no video image on the VRO laptop, here again we can use our knowledge of computer networking to troubleshoot these issues by a process of elimination that again makes use of the ping and ipconfig commands. So let's start by looking at the ISU Cutter screen when everything is functioning properly. We have a live video feed of the ICE on the screen, so it's obvious that things are working. But more times than not, unfortunately, the DS team is required to set up the competition scoring system long before the videographer has arrived. And therefore, we don't have the luxury of confirming that the video replay system is working until the closing minutes leading up to the start of the competition. Fortunately, there are ways of confirming the correct operation of at least the VRO computer and the JTAG device long before the videographer arrives. And this involves looking at the information that appears in the bottom left corner of the Cutter window. Here you'll see one of two messages along with the IP address of the JTAG device that Cutter has been configured for. So in this case, we see a green square along with a message indicating that Cutter has successfully connected to the RTSP video stream provided at the IP address 192.168.6.200. This IP address should match the IP address of the JTAG video streaming box. In the case of Skate Ontario, all of the JTAG boxes that are used have been configured to this address. But it's important that you understand that not all sections use this convention though. Some sections still use the default JTAG box address, which is 192.168.1.168, or your section might have chosen to use a completely different IP address. Let's now compare the last Cutter display to this one. Not only is there no video image, you can see at the bottom left that a red box is displayed and that a message indicates that it's trying to connect to the RTSP stream at the correct location, but the connection is unsuccessful in this case. Let's now compare this screen to the following screen. In this case, a colored test pattern is displayed, and you can see at the bottom left that the box is green, and we have a message indicating a successful RTSP connection. So you might not see a picture of the ICE. This is what you'll see when your video replay system is functioning properly, but there's no video signal being inputted into the HDMI connector on the JTAG device. This is because the test pattern is generated by the JTAG streaming box whenever there is no active video signal. So it's always a good idea to power up the JTAG device during the scoring system setup time, even though the videographer may not have arrived. After giving the box a minute or two to boot up, you should see some sort of test pattern if your system is functioning. And if you see that test pattern, there's a high probability that the video replay system will function as it should when the video camera is eventually connected to it. But what should we do if we don't see a test pattern and we don't see the green box and successful connection message at the bottom left of the screen? The first thing to do is ensure that the correct RTSP stream is displayed at the bottom left. It should read RTSP:/ followed by the IP address of the JTAG video streaming device, followed by /0. If this value is incorrect, which can happen if you have reinstalled ISU Cutter, You can change the value by editing the file called rtsp.ini. To do this, open your hard drive in the File Explorer and navigate to the directory ISU Judging System, and then to the subdirectory ISU Score2FS. Look for a file called rtsp.ini and then edit that file in Notepad by right-clicking the file and selecting Edit. Change the Stream 1 setting so that the IP address matches the address of your JTEC box, and ensure it ends in /0. Once you've done that, save the file and close it. When you restart Cutter, it will connect to the newly configured RTSP stream address. If the JTEC box is powered up and there is a network route between the VRO laptop and the JTEC box, then you should see either a test pattern or a live camera view, depending on whether or not the camera is connected to the HDMI port on the JTEC box. But if you now have the correct RTSP stream address, but you still don't see either a video signal or test pattern, then this suggests that you don't have a network route between the VRO and the JTEC box. This can be caused by a number of reasons. Start by checking the obvious things, such as an unplugged cable or lack of power to the JTEC device. After checking those, the next most likely problem is that the VRO laptop isn't configured to have an IP address on the same subnet as the JTEC device. As we discussed in the earlier modules, if these two devices are on different subnets, or if the VRO doesn't have an IP address, then they won't be able to communicate. I've prepared another downloadable troubleshooting flowchart that you might want to refer to if you're unable to obtain a video image on the video replay system. You can save a PDF copy of this flowchart by either scanning the QR code or using the download link provided below the QR code. So starting at the black diamond at the top left, the first thing we do is look for a test pattern. If you see the colored test pattern, then this means that your system is functioning, and the only thing missing is a signal from the video camera at the JTEC box, typically because the video camera isn't plugged into the HDMI port on the JTEC box. So this would represent a positive outcome at the system setup stage before a camera has been plugged in. If you don't see the test pattern, then start by checking the obvious things, such as no power to the JTEC box or unplugged Ethernet cables. You should also quit and restart Cutter, as this often solves the problem. If you still don't see a test pattern, then check the RTSP stream settings. I've provided numbered notes on the right-hand side of this document. The notes refer to the numbered circles in the flowchart symbols. So Note 1 provides instructions on how to check the RTSP feed settings. If those settings are incorrect, then edit the rtsp.ini file. But if the RTSP settings are correct, then we assume that the issue must be related to network connectivity. So we next see if we can ping the router using the instructions shown in Note 3. As an aside here, you'll recall there are two ways of connecting the VRO and JTEC device, either with or without a router. If you haven't used a router, then it's difficult to isolate the problem to the VRO laptop or the JTEC device. So for this reason, if you have not used a router and you're unable to obtain a video signal, at this point I would recommend plugging both the VRO and the JTEC device into a router or a switch connected to that router. That will then provide a means for checking the network connectivity of the VRO by testing whether the VRO can ping the router. If the VRO can ping the router, then the issue is likely related to the JTEC box. So check again to ensure that it's got power and that the Ethernet cables are fully plugged in. As a last resort, I would swap out the Ethernet cable to the JTEC device. Now going back up to our blue diamond. If the VRO is unable to ping the router, then we would check the network adapter configuration using the instructions shown in Note 4. Well, this takes us to our final quiz time. You've probably figured out by now that my day job is a professor. If I teach something, I just can't help but attach an assessment task to the content. So let's look at 3 final quiz questions to see how well you've mastered the Module 3 information. Once again, pause the video while you write down your answers. We'll then review the correct answers together. Okay, hopefully those questions weren't too hard. Let's review question number 1. After setting up a scoring system, all the LTS computers are able to log in. The ACC can connect to the database, but the announcer laptop is unable to connect. So what do we do as a first step? Correct answer is option C. Try to ping the router from the announcer laptop. So looking at our troubleshooting flowchart, we initially determined that all the hosts are not affected. It really is isolated to just one computer. That rules out an awful lot of things that the problem could be. So then the first step is to try to figure out whether it's a database location setting problem or some other kind of networking problem. And the easiest way to do that is to try to ping the router. Question number 2, how do you configure a laptop to obtain a dynamic IP from the DHCP server? The correct answer, option D. You do this by editing the network adapter settings. An easy way to do this is to type the word control into the Windows search box, then select the control panel, and then go into the network adapter settings from there. And the final question, if you're able to successfully ping the router's IP address from the J2 laptop, what does this tell you? So basically this tells you that the J2 laptop is on the network. It has an IP address and it's on the same subnet as the router. Hopefully you got 3 out of 3 on those very applied questions. If you did, well done. Give yourself a pat on the back. Well, that takes us to the end of this final module. If you have any questions about anything that was covered here, please feel free to contact me. My email address is paul@paulmallet.com. Hopefully the information we've covered has armed you with additional knowledge that will come in handy if you ever have to troubleshoot any networking issues at a competition. Wishing you the very best for the rest of the competition season. Bye for now.